Okay, we're trying to find the max area of a rectangle that has its two lower vertices along the x-axis somewhere and its upper two vertices along the curve y equals 1 over x squared plus 7. Let's focus on this function for a while. This is a rational function. It's got no vertical asymptote because the denominator never equals 0. It's got no x-intercepts because the numerator never equals 0. It's got a horizontal asymptote at y equals 0 because the degree of the denominator is greater than the degree of the numerator. The y-intercept is at 0, 1/7. And it's an even function because something like f of -2 will equal f of 2. So if you take the function of opposites, the y values will always be the same. And f of x is always positive, okay? So there's the graph of that function, that blue line. There's the y-intercept right there. And we want two vertices, the lower vertices of the rectangle to lie along the x-axis and the upper two along that curve. And the key is, if you take the derivative of the function, which I've done here, and applied the first derivative test, you can see that the function is increasing to the left of 0, which means if you put both vertices over here and then try to create a rectangle, you won't have a rectangle because this side is longer than this side. Not a rectangle, it's actually a trapezoid. And the same on the right side of the y-axis, except the function's decreasing to the right. By the way, if you do take the second derivative and set it equal to 0, you'll see that there's points of inflection where the curve goes from concave down to right about in here. It turns around and goes concave up. But that's another matter. The idea is that if we let this distance be x from here to here, then this distance must also be x. And that's because that gives us the same lengths for the width on both sides of the rectangle. Okay, so what we're going to do is come up with a formula for the area of this rectangle depending on this x right here. So if this distance is x, the x coordinate of this point is actually the opposite of whatever this x is. You can see negative 1.95. So the length of this rectangle from here over to here is 2x, and the height is f of whatever x is on both sides, even function. So there's a formula for a of x, 2x times 1 over x squared plus 7. That's a formula for the area, depending on this value right here. If we take the derivative using the quotient rule, we end up with this. If we set that equal to 0 to get the critical numbers, 2x squared equals 14, x squared equals 7, x equals plus or minus the square root of 7, but we want the positive value. So f of radical 7 is 1 over square root of 7 square root of 7. There's the height of the rectangle. Okay, so the dimensions to answer the question are 2 radical 7 by 1/14. That gives the maximum area. And if you wanted to find the maximum area, you'd find a of the square root of 7, which is square root of 7 over 7. So here's a little table that shows the maximum area appears to be right here. That is the square root of 7 over 7, approximately. Okay, everything else is smaller. Board 3, I just added a couple pictures here. This purple dashed line right here is actually the graph of a of x. And you can see that it appears to reach a maximum right here, which that's the square root of 7 approximately. And this little black dashed line is the graph of A prime. And you can see that it hits the actually this point is right here. So actually I don't have this labeled, but that's actually the square root of 7 comma 0. So that is when the first derivative equals 0 at the square root of 7. Okay, there you go. Hope that helped. If you have any questions, post a comment.